Hello, and welcome to episode 9 of Talk Landscape. My name is Eden Flaherty. I'm the multimedia editor at Think Landscape, and I'm going to be your host for today. Well, we're going to be discussing synthetic biology, which has burst onto the news agenda in recent years with articles about topics such as de-extinction, and most recently, at the end of last year, the IUCN's policy on synthetic biology in nature conservation. In this conversation, we're going to be looking at what synthetic biology is, how it can or is being used in conservation, as well as some of the risks it might pose to ecosystems and biodiversity. With me, I have 3 fantastic guests who are going to talk us through this and answer some questions. We have Franziska, who's the head of policy at Save Our Seeds. We have Julia, who served as the co-chair of the IUCN working group tasked with developing the first ever global policy on synthetic biology in relation to nature conservation, and Stefano, the manager of conservation partnerships at the Colossal Foundation, the non-profit arm of Colossal Biosciences. So welcome all, and thank you so much for joining me today.
Hello. Good to be here.
Hello, everyone.
Just before we jump in and start answering some questions, a reminder to everybody watching at home, please drop your questions into the chat because we will be answering those at the end. So to kick off, let's start with maybe the basics of just what synthetic biology is, with maybe an example if we can. Julia, could you just tell us what is synthetic biology?
Sure. Thanks so much, Eden. And I know it seems like an easy question that we started off with, but it really isn't, because of course the discussion on how to best define synthetic biology for the purposes of policy and decision making is still ongoing. So generally, synthetic biology can be described as the field that brings together biology and engineering principles. But part of the challenge is that really we're talking about a set of different tools that can be used in different ways and with different purposes, right? In different sectors, in conservation, certainly, but also medicine, construction, textiles, cosmetics, really many. So just to say, in the process of developing the IUCN policy on synthetic biology in relation to conservation, we chose to use a definition that has been developed as a working definition. That means not as a definitive one, but just something that we can at least work with in the context of the Convention on Biological Diversity, which also has a work stream on synthetic biology. And this definition is basically that synthetic biology is a further development, a new dimension of what we know as modern biotechnology. And what is unique about this then is that it combines science, technology, and engineering to facilitate and accelerate the understanding, design, redesign, manufacture, and modification of genetic material, living organisms, and biological systems. So you talked about examples, but really many things can be done with it, from developing perfume ingredients to develop alternatives for leather bags to really changing agriculture, construction materials, etc.
Fantastic, thank you. That's super broad. So maybe, let's bring it into conservation. Stefano, you work with an organization that I believe uses synthetic biology in conservation. Can you maybe tell us how and why synthetic biology is being used or applied to conservation?
Sure. Thanks, Eden. And this question of why is really important, right? Today, we find ourselves amidst an unprecedented ecological crisis, a 6th mass extinction. And this time we know the culprit, right? We know that it is us that is pushing species, pushing ecosystems, pushing nature to the brink. And unfortunately, traditional conservation tools just aren't enough. We can no longer just preserve the nature that we still have, although that's critically important. But we need to start to think about how to restore some of the things that we've lost and how to help nature be more resilient in the face of rapid change, right? And if we're serious about stopping, maybe even reversing the ecological crisis, then we need bold and disruptive new solutions. And I think that biotechnology and de-extinction technologies, such as synthetic biology, present some of those solutions. So we at Colossal are working on this moonshot mission for nature of bringing back extinct keystone species like the woolly mammoth, species like the thylacine, species like the giant moa, species that were often driven into extinction by humanity and whose ecosystems have suffered in their absence. If we can bring back these lost critters, we can start to restore the ecological functions that they once played and start to rebuild those ecosystems that they left behind broken and out of balance. But perhaps equally as important as this idea of functional de-extinction is that on our quest to bring back these lost animals, we are pioneering novel technologies, advancing conservation science that is directly applicable to the conservation and the preservation and the restoration of species and ecosystems today. So we at Colossal view these technologies such as synthetic biology, as really exciting, hopeful tools for the future because they allow us to address some of the most critical challenges facing our natural world today. Things like climate change, pollution, genetic erosion. We're able to address these in a way that's more targeted, more precise, and more effective than traditional conservation tools have allowed us in the past. So just a couple quick examples of what we are doing here at Colossal. We work with partners all over the world to help species that are threatened with diseases or invasive pests that we've introduced into their landscape and that are wreaking havoc on those ecosystems and the surrounding biodiversity. We're engineering resilience into those species so that they can no longer just survive, but they can thrive in this new era of change, right? For species where only a few remain, the ones that are staring at extinction in the face and face severe genetic bottlenecks like the northern white rhino or the American red wolf, we're pioneering novel genetic rescue tools that combine assisted reproductive technologies with synthetic biology to restore lost genetic diversity and give these guys a second chance at life. So I think for the first time, maybe in human history, we have these incredible tools that allow us to recover nature at scale. And obviously with that comes immense responsibility. Comes the responsibility to deploy these tools ethically, to deploy these tools carefully, to deploy them in ways that are inclusive of all our partners and the relevant stakeholders. But deploy them we must, right? Because the greatest risk is not action, but inaction. And I can't think of anything worse than letting the biological, ecological crisis, a crisis, frankly, of our own making, rage on while we sat back with the tools to do something about it. I think that that's the worst case scenario.
Thank you. It's interesting to hear you talk about responsibility and the ethics of synthetic biology as something that we're going to definitely get onto in a bit. And also, you know, your view there that these are the tools that you think we definitely should be using, because that's not a view shared by everyone. Some people have called for a moratorium on the use of synthetic biology in conservation. And I know, Franziska, you were someone who maybe argued that point. So can you tell us about why some people may hold that opinion, some of the risks or concerns people have around synthetic biology in conservation?
Yeah, thanks for having me, and thank you for this fantastic question, because of all of what we heard, you know, what this is, synthetic biology, and so broad, and all the things it can do, and that we should absolutely use it. I think I want to drive home some very specific, and that's, you know, mostly, you know, for all the things it could be, genetic engineering is what we mean when we talk synthetic biology, okay? So, you know, it's not the study, it really is the engineering of living organisms that's in the center. And that is also the center of the IUCN policy that was adopted last year. And the reason why we have concerns about this really is that you will possibly have to, that's the purpose of many of these interventions, release these engineered organisms into ecosystems. And with this risk comes a lot of problems, a lot of potential risks. And I think that was your question, come from the side of, you know, we need to protect nature. We need to get out of this extinction crisis, and we need to protect nature also from the risks of genetic engineering. So what are these risks? Really, with genetic engineering and with the release of such organisms into nature, you always get, irreversible and often unpredictable outcomes that you cannot control, right? So you get a risk of a massive interruption in our ecosystems. Have unwanted side effects at the level of the genome. So when you make that intervention, it's never quite as precise as what you think it is, or it should be. If you can go noticed, if you don't pay attention. But you also have changes in the way that the organism will, with other organisms, new. You've made a change. So as organisms all interact with others, there will be changes. And even your intended modifications can actually have unwanted effects. So we know that from agriculture, from the herbicide-tolerant plants, which obviously, led to a great increase of use of herbicides, and then these super weeds developed, etc. But think of another example, like we talked about engineering resilience into organisms, right? If you add a heat resistance gene into a certain type of coral, it'll give that coral a selective advantage that others don't have. And along the process, a lot of genetic variation will be lost to adapt to other conditions. So you risk ending up with a worse situation. You're fixing one problem becomes a limitation when problems arise. So, you might immediately have protected that species in the immediate term, but you have reduced genetic diversity and thus put that species at risk in the longer term. So that's just one example, right? And really, from our perspective, it's important to remember that you don't fully control all of this. So once you release this organism into the open ecosystem, the engineered organisms are impossible to retrieve. And so with these approaches, you make irreversible changes that you can't control. And this is not just our view. So more than 120 scientists have supported our call for the moratorium. And they said releasing these products of genetic biotechnologies could cause irreversible ecological disruptions with potentially disastrous consequences for biodiversity. So that's what we are to really be privy. You don't want those disastrous consequences, because in the
Thank you. It's really interesting to hear about some of the risks, and also the number of people that kind of hold some of the views and concerns around synthetic biology for this. Moving on to how it is managed, because this is something that is being used and is kind of appearing more and more, just the governance of its use in conservation so far. Julia, can you explain a little bit more about this recent agreement at the IUCN? You were the co-chair of the working group tasked with developing that policy on synthetic biology in nature conservation. What does that mean in practice? What's that governance going to do? How does it help conservation and just generally?
Yeah. No, great. Thank you. And thanks to the previous two speakers who really, lay out the range of issues and concerns that come into play. The biodiversity crisis, concerns about risk, the fact that synthetic biology technologies are developing and their implementation. And all of this has potential risks and potential benefits. And how do we as a conservation community address this? And what this policy does is make sure that IUCN is prepared, right? So IUCN undertook the most inclusive and participatory consultation process ever undertaken in IUCN. So really taking into account all of the different views of members of basically a citizens consultation within IUCN, and the outcome, to your point about how do we deal with this, is a guiding framework, right? So what the policy does is it spells out in clear terms what to consider in the context of decision making, right, on synthetic biology in relation to nature conservation. So what should decision makers do when coming across all of these questions? And it adopts a case-by-case approach, because it's clear, another thing that we did as part of the consultation process is ask for examples. And the examples and the context of these examples, the technologies involved, the considerations involved, perspectives involved were so different that the case-by-case approach was really deemed to be essential. So what the policy does is it allows for innovation, but insists on scrutiny. And the way that this is done is through the precautionary approach, through an assessment of risks and an assessment of benefits, through respect for the principle of free and prior informed consent, and through encouraging the provision of accessible capacity building. So again, a decision-making framework that IUCN members and beyond can use to guide their decisions, and hopefully with enough robustness and flexibility so that it can be widely used by different entities.
Brilliant, thank you. Stefano, you are part of an organization that's involved in this. You're the nonprofit arm of Colossal Biosciences, which is a company that's working in synthetic biology. And I'd just like to ask you about one of the specific risks around governance that people have brought up with this, which is when you develop these tools, when you develop biotechnology for conservation, some people believe there's a risk that it could be used for maybe harmful applications in what's known as like dual use. So, you develop a biotechnology for conservation and then it's used in a different industry. Like, is this a concern or something that you try and work against?
Yeah, it's a very interesting question, because for us, this idea of dual use isn't really a risk, but rather this incredible opportunity, and at the heart of our model at Colossal, right? So for us, de-extinction and conservation go hand in hand. And de-extinction specifically is this incredible engine that drives massive investments, massive research and developments that we can then deploy, not just to bring back extinct species, but to help species and ecosystems today through disruptive conservation programs. And this is very transformative, right? Because we are not accustomed to seeing conservation as a catalyst of innovation. Typically, what we see is breakthroughs happen in outside disciplines like medicine or agriculture, and then trickle into conservation and get adopted by practitioners much later on. We are flipping that on its head, right, at Colossal, by leveraging de-extinction as this engine of innovation. And you might ask yourself, well, how exactly does that work? Turns out that de-extincting an animal like, let's say, the woolly mammoth is actually extremely difficult. And it requires us to deploy massive amounts of resources, whether that's capital or brain power, into advancing science for non-model organisms like elephants, right? If we're serious about bringing back a woolly mammoth, you better believe that we need to understand everything we can about elephant genetics, elephant fertility, elephant physiology, elephant behavior. So what you're seeing is Colossal invests significant resources into species, wildlife species, that are typically overlooked or underfunded in traditional science. And obviously this helps us with our work in de-extinction and through our disruptive conservation efforts. But like Julia pointed out earlier, these advancements have vast applications beyond the conservation space, right? We have an opportunity to deploy them in things like human medicine, human fertility, agriculture, livestock production, manufacturing, and these breakthroughs can be spun off as separate products, separate companies that generate even more investment, even more breakthroughs that then we can reinvest into conservation. So you see the creation of this virtuous cycle that is generating innovation, is generating investment into the field of conservation. And I think that, this is one of the most underappreciated things of our work here at Colossal. And I think one of the things that is most important to the legacy that we're building.
Thank you very much. That's really interesting to hear. We mentioned earlier, we're going to be talking about ethics because it's not just a practical consideration. It's not just about the practical risks. There's also a lot of ethical considerations around, manipulating genetic data or animals, and even bringing animals back from extinction is something that people think, have concerns around the ethics of. So I have the same question for all of you, and I'm just going to ask you one at a time. What are some of the ethical considerations around synthetic biology in conservation specifically? Franziska, should we start with you?
Yeah, thank you. I think maybe I should just initially say, we're talking, we've heard a lot about de-extinction and bringing back the woolly mammoth. Let's just be very clear. This is about genetically engineering an elephant to have features of the woolly mammoth, right? So let's just be clear. This is not about bringing back a species that once disappeared. I think it's just worth saying on the podcast because it hasn't been said. That this is not actually bringing back the woolly mammoth. It's about a genetically engineered, shall we say, a mammo elephant, right? And like the other projects as well. And I won't go into that because the really important, what are the ethical issues that we're looking at? So I would have three of those. My first question is really, we should ask ourselves whether it's right to use such speculative, unproven technologies that, we've just heard are very difficult to make work in something as important as nature conservation. We've heard it before. The supporters of genetic engineering in conservation say we must use every tool, to save nature. Actually, we've just heard it wouldn't be right not to use the tools. It goes pretty far. I would flip this around and say, so we just can't get this wrong. Like really on the ethics is, what are we looking for in nature conservation? What sort of concept? So for now, I would say we have a protective approach. So we have an approach where nature safeguarding existing biodiversity, respecting ecological complexity and interconnectedness, and supporting natural evolutionary processes. So that's one way of doing it. If we're in that rule that is permissible and that's a tool in nature conservation, we're going to an engineering approach. So we're going to see nature as improvable, something that we want to redesign and optimize, and our question is, how can we fix mistakes that we've made in the past? So it's really two different approaches. And I think that is a very fundamental question, by the way, that we have not been able to discuss in the IUCN. Does genetic engineering have a role at all in nature conservation? I think that is a fundamental question, and it's to conserve the integrity and diversity of nature. What we've been able to discuss is how do you go about individual projects, individual proposals, and that's what the policy is about. So just my last point here, do we want to spend time and effort on something that is not necessarily going to solve our problem? So let's face it, species go extinct because they lose their habitat, right? Due to rising temperatures, but also due to human activity more directly. So it will be farming, forestry, fishing, hunting, etc. So there are good reasons, bad reasons, of course, why species go extinct. So we need to make changes in these areas. We need to basically, stop deforestation. We need to restore river, regulate hunting, etc., etc. All this is really messy. And here, the big thing to do is we bring on technology, and we innovate our way out. And really is a distraction from what we should be doing. So I think that is a very fundamental point. Like, ethically, is that the right way to go? And I want to just add that distraction is not hypothetical, it is real. So in the US, the promise of genetic engineering technology, and specifically of de-extinction in the sense of Colossal, has certainly helped regulators think they can water down needed protections for species and habitats. The State Secretary of Interior, when that big news, the engineered wolves, the so-called dire wolves, he completely embraced that and changed course on conservation. I mean, he would have changed course on conservation, but it really has, I think, worked well for him to go for nature protections, etc. And I want to quote that, he said, Doug Burgum said on the 7th of April, so just as the news broke about those two wolves, the marvel of de-extinction technology can help forge a future where populations are never at risk. Sorry, this is bollocks, it really is a distraction. I think that's the last point that I wanted to out of three. Thank you.
No, thank you. This is actually going to be one of the next questions about whether technological approaches can distract from some of the root causes. This is something that is not unique to conservation, and I don't think it's unique to synthetic biology. We've also seen it in other areas such as carbon and carbon removal. This is a conversation that's happening in various different places. So Stefano, let's just jump straight to you, because this is a question I wanted to put to you about the risks and maybe mitigating the risks of technology overtaking or shifting focus away from the root causes of nature loss.
Yeah, man, my colleague Franziska brought up a lot of good points that I want to respond to. I think let's address this idea of taking away attention from the root causes. As an ecologist, as a conservationist, as someone who works for a conservation-driven company, I can't think of anything more important for us and for society to do than to double down on traditional. Right? We need to be expanding habitat protection. We need to be accelerating species reintroductions. We need to be passing smart policy that protects animals and their habitats. And we do not see those things as optional in the face of new tools. Synthetic biology and biotechnologies are not competitive to traditional conservation. They're complementary. And actually, when used together, they become force multipliers that allow conservation practitioners to do their jobs on the ground at scale and more effective, which is crucial for an industry like conservation that is notoriously underfunded. One of the questions that I often get that is very similar to this idea is, will de-extinction divert resources from traditional conservation efforts? And the truth is that it's quite the opposite, right? Every single dime that Colossal has received an investment today, all of that has come from private investors, people in the innovation and technology space, people who are not renowned for writing million-dollar checks to conservation organizations like WWF. We're able to bring this new capital in and deploy it into accelerating species restoration and disruptive conservation efforts and accelerating on-the-ground traditional conservation partnerships. So we are growing the conservation funding pie rather than shrinking it. And I think that this is a very critical point, right? I just recently read this article by the Poulsen Institute that said that if we want to stop and reverse biodiversity loss, global conservation spend needs to reach about $960 or so billion. That figure today is closer to 140 billion, right? So let that sink in. This isn't a funding gap that we're facing. This is a funding chasm. And it reveals that the way that we fund conservation today is fundamentally broken. We are overly reliant on philanthropy. We are overly reliant on the whims of governments that, their priorities change with the coming and going of administrations. And what Colossal is doing is bringing in a new model of financing nature recovery, one that is innovation driven and provides long-term sustained investment, which we need if we want to build momentum and build the foundation to long-term nature recovery. Like Doug Burgum said in that statement, we can't legislate our way out of this crisis. We need innovative new tools, innovative new solutions, innovative new models of funding. And just to reiterate, we do not want to take away from traditional conservation. We want to be a force multiplier. We want to help accelerate and scale these efforts that are so critical to helping stop this existential crisis of nature loss.
Thank you very much. It's really interesting to hear kind of two quite different sides of this about synthetic biology in conservation, bringing it maybe a little broader and back to kind of the more general ethical considerations. Julia, tell us maybe a little bit about what are some of the general ethical considerations around synthetic biology and conservation, please?
Well, the interesting thing, and again, the approach that we took is not to come to general conclusions. So if you look at the policy, there's a specific principle which is taken from Resolution 123, which set out this process, and it calls on decision-making to be science-based, encompass other authoritative information, including traditional knowledge, and considering ethical principles and a plurality of values. So I think this strong recognition that we cannot be the ones to make a general statement, but have to set up a decision-making process where the plurality of values and of perspectives is brought in. So I think this is an important part of this case-by-case approach. I want to highlight that the policy is not for or against synthetic biology, but it's really this recognition that there's a range of situations and a range of needs. And I think it's very much not, either or synthetic biology or something else or at the expense of something else. But there we heard so many voices, and obviously Colossal is doing work in one sector of conservation and of synthetic biology, but we heard from many conservation organizations, traditional conservation organizations that are greatly concerned about coral reefs or species on the brink of extinction or invasive alien invasive species and their impact, for instance, on island species, where there was an urgency and the call for a decision-making framework to be used to frame, again, taking into consideration all of the risks, but also the urgency of this situation. So it's really very much about looking at the specific situation and providing this framework where the ethical considerations, the scientific considerations, the uncertainty, and obviously the precautionary approach where relevant come in. So I think that's kind of the approach from the ethical perspective, not to decide, but make sure that those are considerations that are brought into the decision-making process.
Brilliant. Thank you very much. A reminder to everybody watching on the various platforms that we're going to be moving into a bit of a Q&A now. We've already got a few audience questions in, which I'll share with our guests, but please drop any questions you have into the chat because it'd be great to have some input from you as well. So onto one of the questions that we got from somebody watching. It's about what conservationists are doing to integrate indigenous peoples and knowledge into conservation practices. So I guess to make this more specifically about synthetic biology, what are some of the, I guess, risks and opportunities, or how, do you balance kind of indigenous people's knowledge and traditional knowledge and practices with these new technological approaches? I don't know if anybody wants to put their hand up to take a crack at that question. Yes, please go ahead.
Yeah.
Franziska afterwards, if you want.
I'd love to hear from all my fellow panelists, but I'm really excited that this question got asked because obviously Colossal has a deep interest in ancestral species. And we know that if we are serious about bringing these species back and restoring ecosystems, we need to be working with the people with the deepest connections to the land, to the biodiversity. So early on at the foundation and through our conservation efforts, we created an indigenous council that came about us engaging with different tribes, different tribal organizations focused on conservation, and figuring out how best to work with indigenous peoples, not just informing them, right, but having them be engaged and included and involved from the beginning in de-extinction and in deploying these tools for the conservation of species that they really care about, that have deep cultural ties to their tribes, to their lands, etc. Here in the United States, a lot of those animals are bison, beavers, condors. So we've launched a few initiatives in deep collaboration with indigenous partners. Just 3 really cool examples that I'm really proud of. In July, when Colossal announced our intentions to bring back the South Island giant moa, the tallest flightless bird that has ever lived, that was native to the island of New Zealand and went extinct just about 600 years or so. When we announced that intention, even though it was super exciting, what I was most excited about was that we had partnered with the Ngāi Research Center, the Ngāi being the largest iwi tribe of the South Island, to lead that effort from all aspects of the work, from the de-extinction side, acquiring new moa specimens to sample and sequence, to the eventual restoration of those animals. Where on the landscape are they going to go? Who are the key stakeholders that we should be engaging with? Other iwi tribes, other government officials. So Colossal, in this sense, is acting more kind of as a technical partner, and the Ngāi who are leading it, which is really exciting. Also, when we announced the birth of our de-extinct direwolves, we also announced, to a little bit less fanfare, but maybe even more conservation significance, that we had cloned 4 ghost red wolves. These are red wolves that carry genetic diversity that are currently not represented in the recovery population of red wolves in zoos and in North Carolina, and can help bolster the genetic resilience of that bottleneck population. And when we announced that, our partners at the Karankawa Tribe of Texas, which is an indigenous group native to the Gulf Coast here, that co-lived with red wolves and ghost wolves for a long time, they reached out to us and they said that they would love to bestow a naming ceremony for our ghost wolf, our first female pup, who was initially called Hope because she provided hope for her species. They wanted to bestow the name Nekakaida, which in the Karankawa language means the ghost daughter. And they made Nekakaida the official totem animal of the Karankawa Tribe of Texas, a tribe that eerily was also thought to be extinct by Texan historians, etc. I love that story so much. And then the final one that we just announced actually is one of the members of our Indigenous Council is the Nez Perce tribe of Idaho. They're known for being these leaders in wolf restoration, helping bring wolves back to Idaho and Yellowstone during the 90s. And when they reached out to us about supporting and working with and adopting some of the technologies that our teams are developing, they told us that they were also very interested in restoring the California condor to their native canyons. This is a species that hasn't existed in Hell's Canyon for over 160 years, right? And they just wanted financial support, genetic support, and helping them create that program. So we just announced a month ago a commitment of $500,000 to help put the California condor, known as Cunas in the Nez Perce language, back in Hell's Canyon. So we're looking for ways of engaging, supporting, partnering with indigenous peoples all over the world. I think we built a really strong foundation, but that foundation is only going to grow as we continue our work here at Colossal and the foundation.
Thank you very much. And Franziska, I'm going to jump straight over to you with the same question.
On the indigenous peoples, right? Yeah. So I just wanted to add that there are different perspectives in the indigenous peoples and local communities around the world, and we had support, for this call for a moratorium, for deferment, of using these technologies in conservation, also on the side of indigenous peoples. And the argument really was that they felt this could sideline them, that could sideline their knowledge and their traditions and their role as stewards of the land. So, they did feel threatened, and their relationships with nature, with their land, could be threatened. So there are different perspectives. I think it's worth remembering that that also among indigenous peoples there are different perspectives and inputs into this debate. I wanted to come back quickly. I don't know if this is the moment, to 2 points that were made. One is on the foundation increasing the pie. I don't doubt that, that you're putting money into this field of conservation. But of course, under one condition, it's your type of conservation, right? So when I was saying, we have perhaps a more sort of protective or like traditional type of conservation, and then you have this, what you're advocating, technology-based, engineering nature. I think the foundation will very much support one type, and it really is about, I think it says on the website, rapidly flowing Colossal's technological advancements into the field of conservation, revolutionizing the field of conservation. So just to say, it's not any old conservation, it's your type of conservation, which we can argue about whether that is the way forward. And just coming back to the policy, I mean, we hear that again and again, the IUCN's policy on synthetic biology and nature conservation is not in favor or against. Well, as a matter of fact, it was picked up as, opening a door, as green lighting, the use of these technologies, which was not until now something that the IUCN viewed positively. So I think we just can't get around that. So it is something, that is a change and a massive break from previous positions of the IUCN. So if it's a yes, but, I hope the but and the conditions and the precautionary approach will prevail. For the moment, it's a resounding yes in the perception. Yeah.
Thank you very much. Franziska raised a couple of other points there, so I think it's only fair that if Julia or Stefano, if either of you would like to respond to any of the points she raised before we move on to another audience question.
I guess I would just say, yeah. I mean, there's obviously very, very different perceptions around these concepts, and I think as the discussion today shows. So I think what will be very interesting is that, of course, if we look at the policy, it is a set of principles and a set of considerations that need to be put into practice. So perhaps I'm already moving forward to kind of closing words here, but I think the implementation will be really important and interesting. And I think that will be the place to look at how some of these issues are resolved in practice, because ultimately, again, it is about the specific situations. And the more that we can translate then and use this policy in specific situations, we will be able to see how it really plays out. So, I mean, I think it's an interesting days ahead.
Thank you very much.
Can I
please go ahead? Yeah.
Well, just on the previous point, Franziska, of we're accelerating supporting our type of conservation. I think you do hit on something, that we are focused on applying tools and approaches where traditional conservation has fallen short, right? No amount of traditional conservation efforts today will save the northern white rhino. Only 2 remain, and those are 2 females. Mother and daughter, no matter how much they love each other, right? They're kind of doomed to extinction because we poached them out. So now it takes tools like assisted reproductive technologies, genomics, synthetic biology to bring that animal quite literally from the brink of extinction back. So we do want to create opportunities to recover critical issues where traditional conservation, unfortunately, isn't enough. However, as I said, with our efforts with indigenous partners, just as an example, that commitment to help restore condors, that is us not deploying de-extinction technologies. That's us giving them a financial commitment so that they can build on, reintroduction plans, that they can do engagement with the community, that they can build facilities. So we are indeed supporting traditional approaches. We are engaging with local landholders, indigenous groups, because we want to do so responsibly. And then just another, if you don't mind, I want to address the question that you brought up, that we are not bringing, exact carbon copy replicas of these extinct animals. And us at Colossal, we're focused on this idea of functional de-extinction, right? We're using genomics to sequence the genomes of extinct animals, identify the unique genes and traits that made these animals unique, contributing members of their ecosystems, and then restore those genes and those traits in their closest living relatives so that we can restore those ecological functions. We're not creating carbon copy clones of these animals, because in order to clone an organism, you require a living, viable cell. And unfortunately, when an organism dies, its cells die, its DNA starts to break down, rendering this cloning process almost impossible. So the next best thing is to rebuild these species to be able to thrive in the modern day by working off of their closest living relative. In the case of the dire wolf, it was the gray wolf, which we identified as being 99.5% genetically identical to the dire wolf. So this is an organism that resembles the extinct relative, both genetically and physically. And we identified some key traits that made dire wolves unique. More muscle, right? Stoutier, light fur. And we were able to restore those genes using CRISPR and other multiplex gene editing tools, dire wolf genes that have been extinct for over 12,000 years, to recreate those traits in those relatives to de-extinct the dire wolf. So, this is what we're doing. We're focused on doing this for a number of keystone species, and then deploying those technologies to help species today. So we've done a lot of excellent work with red wolves today as a result of our dire wolf project, as I mentioned with our red wolf project. So I think it is innovative technology. It's new, it's different, but it's important, and it shouldn't be ignored or shunned because it's different.
Thank you. I don't think we're going to probably reach a consensus on this call, and it's more about bringing these different perspectives, which is really interesting to hear some of the kind of arguments from different areas. I would like to try and get in a couple more of the audience questions before we move on to closing words. I will give each of you a couple of minutes at the end just to kind of say anything more. So if we just respond directly to these questions, that would be great. The first one is, I wonder about the risks of bringing back diseases. Is that a possibility? So I guess this is related to de-extinction, but perhaps messing around with genetics a little bit broader. Like, is there a risk of kind of diseases that we've never seen before suddenly appearing? Like, is that something that people should be scared of?
Just really quickly from our end, because we're focused on this idea of functional de-extinctions, we're not cloning exact carbon copy replicas. We're not reviving from the dead these organisms that carried extinct viruses or diseases with them. So even though it may seem like a concern, it's not a valid fear that we have. And in fact, we're focused on helping address diseases that species today have, so that we could help them be more resilient in the face of those emerging threats. Thank you.
I hope that quells that fear of old ancient diseases coming back. The other question is a little bit related to the funding that we've been discussing. Is there a middle way between generating media and investment traction for iconic species while maintaining scientific consensus? How to generate hype for the traditional conservation message? So how can we, de-extinction has hit the news, and it's very, very good at kind of gaining traction for sure. How can we generate that kind of hype for more traditional conservation messages, perhaps? Anybody want to jump in on this? This is the $1 million question, literally. So
I think this
Exactly.
is keeping all of us. Yeah, exactly. But I think one point, and maybe from my work more generally, is we do need to. I mean, we've talked about biodiversity crisis, and it's easy to get discouraged. And I think, part of the appeal of the technologies is the hope, right? It's something can be done. And I think, for the use of whatever tools for conservation, we do need to look at opportunities, so even for, the more traditional, what are the opportunities? What are the ways in which we are succeeding? And I think that's a key narrative that we need to explore. Something that brings all of us together is, I think we love nature, right? We recognize the importance of nature. And I think that is true for everybody listening today, but also everybody around us, right? So the more that we can tap into that, not from a place of fear, but from a place of opportunity and contribution and beauty, I think that's what gets people involved. I don't know if I'll get the big funders involved like Stefano knows, but hey, we can try.
Fantastic. Thank you. And I think on that note, what we'll do is we'll move just onto the final section where I'm going to hand over to each of you. I'm going to give you 2 minutes, and just 2 minutes each, to give some final words, mention anything that we didn't cover so far that you think needs to be said, or potentially just to make some recommendations for people to learn more about this topic and maybe dig a bit further. So Stefano, should we start with you? Do you want to give your 2 minutes, your final words?
Sure. I hope I can stay within my 2 minutes. So one of the big questions that I often get asked is, are you playing God, right? And it's often asked with a little bit of apprehension, which is totally normal, because it's okay to be cautious, maybe even skeptical in the face of these powerful new technologies. But I think it's worth pausing and kind of thinking about what is really being asked here. Humanity plays God every day, right? We play God when we go to the doctor and take medicine. We play God when we hop on a plane and fly across the world. We play God when we irrigate our crops and walk into a grocery store. And even within the field of traditional conservation, we've been playing God for decades. We play God when we decide what animals to protect and what ecosystems to protect, or what invasive species to control. These are moral choices, and they always have been. So I like to rephrase the question and ask, are we okay continuing to play devil? Right? Because just like we play God on the natural world, we've been playing devil for a long time. As Franziska said earlier, we destroy forests, we overfish our oceans, we poach animals into oblivion. And unfortunately, these negative activities become normalized and they become business as usual. And now, all of a sudden, that we have these powerful technologies to not destroy, but to repair the world at scale. Now we're hearing people who are skeptical or opposing these technologies say, well, hold your horses, you're playing God. So I think really ethically, the question is not so much of should humans have influence over nature, because as a matter of fact, we have, and we have had it for a long time. I think the question is, should we take responsibility for that influence? And synthetic biology demands a lot from us. It demands that we act with caution. It demands that we act with restraint. It demands that we act with transparency. But it also asks something deeper. It asks if we're willing to transform ourselves from these agents of destruction into agents of stewardship and repair. Because ethically, if we had a hand in bringing about a crisis like the ecological crisis, then we have a moral obligation to ethically and carefully start to mend what we've broken. I think it's our responsibility, not just for us, but for future generations.
Thank you very much. And I'm just going to hand straight over to Franziska, 2 minutes, if you want to share any kind of final thoughts and final words.
Thank you. Thank you. Yeah, I completely share the point that we have responsibility to bring back nature. I wouldn't completely agree with the way you described it, how we do that, and what the role of technology in that would be. 3 points from me. First one, don't get blinded by terminology. So when you hear synthetic biology, just think genetic engineering. It's not as complicated. Then second, really don't think it's as simple as it sounds. So, it is when we play God, as we just heard, it is more difficult. We are not God, it is more difficult than that. It's very uncertain. This is speculative more than anything else. And testimony to that is that very little has so far materialized. I think it's worth remembering that a lot of the promises that were made about genetic engineering have not been met. And just one small example, I like the example of the American chestnut that was supposed to be saved by genetic engineering from a chestnut blight, from a fungal disease. So 10 years ago, there was no hope. We were thinking, but they're all gone and there's no way to save them. And then an idea came up to engineer a wheat gene into them and to save them by genetic engineering. And in the meantime, that hasn't actually delivered. But what has happened is that, in parallel and at the same time as these genetic engineering proposals are coming through and are actually being trialed in the field, we see resistance evolving. So nature is robust. So, just to say this may or may not work, nature often has the solution. And I'm not saying has all the solutions, but, it's more difficult and we may have to fix the fixes, in the end. And then my last point, let's really do what we know works. So we need to scale efforts. We need to go to the root causes of species extinction. We need to protect habitats. I think that's the most important thing, not species by species. Let's, the rhino and the elephant. No, it's the habitat that we need to protect. And there are various ways of doing that. So yeah, let's get going. Let's do it. Really the hard way. That would be my message.
Thank you very much.
Thank you very much.
And finally, Julia, do you want to give us a couple of minutes?
Fantastic. I'm just going to be super brief. The real importance for us of the IUCN policy being adopted is that it shows that we can have a dialogue and we can engage constructively and move forward. As Franziska was saying, let's do it. Let's look at this. Let's engage, right? And I think this is the responsibility of the conservation community to see how to engage and have a strong, robust basis for dialogue and engagement with these topics. And so I guess my closing words would just be to ask, the listeners to, if there are opportunities, if you're working in conservation and you want to discuss this, you want to understand it, you want to see how the IUCN policy might be implemented in the context of your work, if you're interested in understanding how it works, please do reach out to IUCN. We are keen that this is not just a piece of paper. It reflects a very long discussion leading up to that little piece of paper, and I think it can hopefully then now blossom into a very inclusive and widespread implementation in different circumstances where this issue comes up. So thank you so much, Eden, for the opportunity to be here.
Thank you very much. And thank you to all three of you for joining. I'm really glad that you were able to find the time. It's been a fascinating conversation, and I'm sure our audience thought so as well. Please stay on the line because we're going to be closing this stream in just a second. But yeah, thank you very much all for joining.
Thank you, everyone.
Thank you.
And thank you everybody at home for joining the stream. I hope you enjoyed the conversation and I hope you enjoyed episode 9 of Talk Landscape. We've got plenty more coming throughout the year. And if you want to be notified about those, the easiest way is to sign up to the newsletter. This will allow you to find out the upcoming Talk Landscape episodes. There's also newsletters for the Think Landscape feature article each week and a monthly wrap up of news around nature. Thank you everybody for joining, and I'll see you next time.